All right, now we're going to use vectors to solve this problem. So this says that we have a pilot, and he's going to take off from Chicago and head west to Denver. This plane is traveling at 288 kilometers per hour west. We need to calculate the plane's relative velocity to an observer on the ground if the following things are happening. So the cool thing about this is for all of these, we have this plane and it's traveling 288 kilometers per hour west. So we can use a vector to draw that. So we have this 288 for each of these scenarios. And even this one over here. Now, if we keep reading, then we learn we have other things going on. So this very first condition that we have here is a headwind of 25 kilometers per hour. Now, you can look at the direction or you can stop and think about what a headwind means. So we're talking wind at the head of the airplane. So if the plane is flying west, and we have wind coming at the head of the plane, it's going to be going in the opposite direction. So this is the 25 here. Now what happens when wind is hitting the head of the plane, or our vectors are in opposite directions, is we subtract the two measurements. So we end up with 288 minus 25. And if we throw that in our calculator, we end up with a nice pretty 263 kilometers per hour, and it's still overall going west, because even when you have wind at the head of the plane, it's still traveling in the direction that you're going in. So then now this next one is just about the same thing, except this time we have a tailwind. Now this means wind at the plane's tail. So think like it's wind pushing on your butt, making you go faster. So we have 67 kilometers per hour in the same direction that the plane is going in. So for this one, instead of subtracting, we're just going to add these two speeds up. 288 plus 67, because that wind is helping us in this case. And we end up with 355 kilometers per hour. And again, we're still traveling west. This time we're just traveling a little faster. All right, now comes the hard one. So a side wind is usually what happens. It's not directly at a plane's front or back. It usually comes up at the side. Now what this is going to do is kind of push us in a diagonal direction. So you can see if we read it, it says we have a side wind of 43 kilometers per hour north, meaning that the wind is pushing the plane this way, or north, 43 kilometers per hour. So if you take a look at this, it makes sense that the plane is really traveling like this way, right? So we need to figure out how fast it's going and then what that direction actually is. So what we're going to do is we're going to turn this into a right triangle, because we can do a lot of math with a right triangle. So same thing. Let's just turn it into a triangle. And we need to find two things. We need to find this measurement right here, because this will tell us how fast we're going, because we can't just add like we did here, and we can't subtract like we did in the first one. And the other thing we need to find is, because we're not heading exactly west, we're heading at some sort of angle here. We need to find this angle. And remember, this symbol right here is theta. That's like x for an angle. So let's find x first. Let's find out how fast we're going, because that's a little easier. You guys in several math classes have done Pythagorean Theorem, and that's what we're going to use here because we have a right triangle. So remember, Pythagorean Theorem says that you can take your sides, square them, and add them together, and it equals your hypotenuse squared. And your hypotenuse is always across from the right angle. So it doesn't matter which one of these you call A and which one you call B, so let's just plug them in. And then we don't know what this one is. And then we just let our calculator do some work. So 43 squared is 1849. 288 squared is a big number, 82944. And we add those up. 84793. And then remember, to get C by itself, we got 2 square root both sides. So again, throw that in your calculator. We're going to end up with a decimal, but it's 291.2. And remember, this is our speed, and it makes sense that we're going a little bit faster than the original plane because it is kind of pushing us in that west direction, but it's moving us north too. So here's our speed. Now the next thing we need to find is we need to find the direction, because remember, we were tasked with finding velocity, and velocity has both speed and direction. So this is where you're going to need some trig functions. You've learned these in some math class, so if you need some more practice, just let me know. But the one we're going to use here is tangent, and that's because if we look at this angle right here, this side that we have is our opposite side, and this side right here is our adjacent side. And tangent of any angle is opposite over adjacent. If you don't remember this from math class, you just have to know how to use this equation. So I'll give you this. You won't ever have to memorize it, but this is like the SOHCAHTOA. This is the TOA part. So let's plug in what we know. We don't know the angle, but we know our opposite side is 43, and we know our adjacent side is a number 288. So now what we have to do is we got to get rid of this tangent over here. So to do that, if you remember from your math classes, we have to use inverse tangent, and this is just a button in your calculator. So that crosses this off, just like the square and the square root cross each other off, and we're left with our angle is the inverse tangent of 43 over 288. So to find this on your calculator, you're going to find where it says tangent, T-A-N, and right above it is tangent with the -1. You're going to have to hit the second key to get to that. And if you're using your phone, there's a second button for that too. So you're going to click second tangent, and then you're just going to type in 43 divided by 288, and it's going to spit a number out. And it spit out 8.5. And remember, this is our angle, so it's 8.5 degrees. Now, this is the part that gets a little tricky because we have to like put all this together. We got to put the speed and the direction in our vector terms. So remember, we have our number first. I'm going to come over here because I'm running out of room. 291. And remember, our units are kilometers per hour. And then we need our direction. So remember, it's got to be in parentheses. And remember, our angle is down here. We were going west, and then we got pushed north. So we're going to say west, and then we went 8.5 degrees towards the north. So this whole thing is our answer to the third one. Obviously, these first two don't take much work at all. This last one takes a lot. So I want you guys to try all three of these with just different numbers, and let's see how we do.